Hey, welcome back, Casibang's crew. We are starting Unit 5, which will be our last unit for Semester 1. It is all about sensation and perception. This first video is really going to go over a very brief overview of things that we are going to talk about. It's very, very vocab heavy. So obviously these are vocab words that you are going to need to know for this unit. So the first set of vocab words are the words sensation and perception. So what are we going to be talking about in this unit? So sensation, these are all of our senses, our 5 senses. We've known this since what? Kindergarten or first grade, right? So hearing, sight, touch, taste, and smell. We're going to delve deeper into all of those things. So sensation is how you experience your environment by bringing in energy through your eyes or through your ears or through your hands or through your nose. Okay? So that is what sensation is, how you experience your environment. Perception, on the other hand, is how you interpret that energy. So how you understand your environment by interpreting your sensations. Okay, you are both sensing and perceiving right now by listening to me and by reading what's on the slide. So a couple of examples. Sensation and perception always work together, and that's why we study it together. But oftentimes sensation and perception, those two words, are used by people that don't really know better, are used as the same thing, and they're really not the same thing. So for example, in your hearing, you sense the noises that the vocal tract makes when a person speaks. So you're sensing what I'm saying to you right now. You perceive, or your perception of what you are sensing is the meaning of what those noises represent to you. So you understand the words that are coming out of my mouth. So that is the perception part of it. If you're experiencing a health problem, you might sense pain in your tooth, say for example, but what you think about or what you assume or what you interpret from that pain might be that you have a cavity and you need to go visit the dentist. Right? So they do always work together, but the sensation is more, you might think of it as more sort of like the biological. That's what's coming in to your senses. And the perception is your cognition. What are you doing? How are you interpreting it? How are you solving the problem? What are you thinking about that particular sensation? We're going to do this in class, so I'm going to skip that. Okay, so bottom-up processing. Bottom-up processing is what we associate with sensation. So bottom-up processing is an analysis that begins with our sensory receptors. So it transmits this information that we're getting in from our senses to the brain to be processed. So for example, if you look at the image that I have right here on the screen, you might start by analyzing each individual line and each individual intersection and each individual corner and connection, and then finally figure out that it is a cube. Right? You just used bottom-up processing. So this bottom-up processing is something that we usually use when we're experiencing something for the first time. So if we're seeing an image of something for the first time, we're going to analyze all the small bits and parts of it to try and figure out what it is. Whereas its opposite, or its confusing pair, so put a star next to these because it is a set of confusing pairs, is top-down processing. So this is more associated with perception. So this is analysis that is guided by higher cognition. Okay, so experience, knowledge, motivation, expectations, those things that help us identify information really quickly. So you've all seen a cube before. You've talked about it in geometry. You may have drawn them because it's a fun thing to draw. So now that you've seen a cube before, you don't have to analyze all its small bits and parts. You know right away from your previous knowledge that it is a cube. So top-down processing and bottom-up processing. So the way that I tend to remember them is top-down is our brain is at the top of our head. So we're using our cognition, our cognitive abilities. So we're starting at the top to process information. Okay, whereas bottom-up is we don't have any information yet and we need to bring that information up and into our brain. Okay, hopefully that sort of mnemonic helps you with that. Okay, so test yourself on top down, bottom up. Here are just small tidbits of a picture of celebrities. So take a second and see if you can figure out who each of these celebrities are by only seeing a very small part of their head. Okay, can you guess who they are? Pause it and take a second. All right, so here are our answers. Okay, did you get them correct? Okay, did you get them correct? Were you able to use bottom up or top down processing to help you with this? All right, so here's another image, and these are the thing that I think is really cool about this unit is that we get to analyze a lot of different optical illusions, and here is an optical illusion that you may have seen before. So if we're using bottom-up processing, you might see black figures, you might see white figures, you might notice shapes and particular angles, if you see here, but you might not recognize it without using top-down processing. So in top-down processing, if you've already seen this image, which is called Vases and Faces, or if you maybe just saw the title and read that it was Vases and Faces, you're able to better analyze this image and see the optical illusion. So the black are faces. I see here you can see the nose. And the middle, the white section here is a vase. All right, so a couple of the things we talk about in our senses and in our perception are things that are all under this sort of umbrella term of selective attention. So the first thing is cocktail party effect. If you've ever been at a party or a big gathering with a lot of different people and you know, there's music on in the background and you know, there's different groups of people that are having different conversations and you're really focused in on the conversation that you're having, you know, with your boyfriend or your girlfriend. And then all of a sudden, across the room, you hear your name and you're like, wait, what? So even though you weren't paying attention to that conversation that was going on the other side of the room, you focused in on something that was really important to you. Your name. And even though you really were paying attention to the conversation that you were having with your girlfriend or boyfriend, the minute you heard your name, your attention, your focus, your perception was pulled away. That's the cocktail party effect, literally named for the cocktail party. Selective attention, multitasking. I don't think I've had this conversation with you in class yet, but multitasking is not a thing. Right? Everyone says, oh, I'm really good at multitasking. It's okay. It's really not a thing. Your brain cannot focus 100% of its attention on more than one task at a time. So you might think that you're multitasking, like I'm doing homework and I'm listening to music and I'm, you know, on Snapchat answering my friends' snaps. But really, your brain is divided. You're only spending, you know, 50% of your time on your homework, and you're spending 10% of your time listening to your music, and you're spending 40% of your time on Snapchat. So you're not giving your 100% focus to any one thing. This is why the picture I have there is, you know, texting and driving. It's never a good idea to text and drive. You're splitting your focus. So you're not giving 100% of your focus to driving when you are doing things like that. Inattentional blindness is just our ability to focus on one particular item and not notice other things that are going on around us, particularly if we're instructed to focus on one particular item. And when you come to class tomorrow, I'm going to do a demonstration of this for you, so it'll make a little bit more sense. And then change blindness is, again, our ability that we might be focusing so heavily on one particular sensation or one particular thing that you may not notice that things change around you. And again, I'm going to show you a demonstration of this tomorrow in class. All right, so perceptual adaptation. So this is our ability to adjust to altered visual fields. Okay, this is specific for your visual fields. So if I asked you guys to walk around with a patch over one eye, it would be really difficult for you to walk around for, you know, the first few minutes, maybe up to an hour. Okay, it would be really difficult. You would really notice. But then after that, our visual system has this amazing ability to adapt to what's going on. So even after about an hour, your vision would adapt. You would forget that you had the eye patch on your eye, and you would still be able to do everything that you would normally be able to do. During our sensation fair, which is going to happen the day before holiday break, you're going to get the chance to wear some inversion goggles and see how long it takes your perception to be able to adapt to that different sensation. Transduction. We're going to be talking about transduction a lot throughout this unit. Transduction happens in every single one of our senses. So transduction is literally the energy that is entering our sensations, changing from one form to another. And it has to change from one form to another to be able to be processed by our brain. So we'll talk about it specifically when we talk about vision and when we talk about our hearing or audition. We'll talk about how that energy that enters our eyeball, for example, is changed within our eye so that it can be processed by our brain. It's pretty cool, actually. All right, absolute threshold. So absolute threshold is the absolute minimum stimulation that is needed for you to be able to perceive a stimulus half of the time. Okay, so what this tells us is the limit of our sensation. And this is based on the population, like human beings as a whole. So it could be different individually for each person. But absolute thresholds that have been studied and recorded are, for example, a single candle flame from 30 miles away. Would you be able to see a single candle flame from 30 miles away? Or a drop of perfume in a 6-room apartment? Or the ticking of a watch from 20 feet away? Okay, those are some absolute thresholds of our perception. And then the next one, and again, a set of confusing pairs here, so you want to put a star next to those. The next one is difference threshold, or it's sometimes called just notable difference. And that is sometimes abbreviated to JND, so write that down for yourself as well. So this is the amount that two of the same stimuli must differ for a person to notice the difference at least half the time. So difference threshold is based on Weber's law. Difference thresholds differ by a percentage, okay, rather than a specific amount. Okay, so it's always going to be reported, difference threshold will always be reported as a percentage. So for example, if you look at these two images right here, okay, how much of a difference do you need to see between the left-hand side and the right-hand side for you to be able to tell the difference? And again, always reported in a percentage. Or if you were holding two, like our guy here, two dumbbells, or say you were holding a piece of paper, like a loose leaf piece of paper or a piece of copy paper, how many pieces of paper would need to be added for you to be able to tell the difference between one and more? Okay, so again, reported as a percentage. Sensory adaptation. Okay, so if you've ever noticed, if you've jumped into a pool in the summer and it's really super cold and you're like, oh my God, that's really cold. But then like a minute later, it's super comfortable and you're encouraging other people to come in, that is sensory adaptation. So repeated stimulation will no longer experience that particular sensation. Okay, so This is our brain's way of being able to help us focus on changes in our environment, but not overly focus on those changes. So my example, water is cold at first, but then you get used to it. Maybe in one of your classrooms there, like a light is making kind of like a buzzing sound, and you notice it at first, but then it kind of goes away. You stop feeling your underwear, okay? Or maybe you have glasses on your face and you stop feeling the fact that you have glasses on your face, or you are wearing a watch, okay? But you forget that it's there after a while, okay? The only thing that sensory adaptation doesn't really work on is our vision, okay? Why would it be important for our vision to not go away? Okay, think about that and write that down. Why would it be important for our vision to not go away? All right, and then the last thing, influences on perception. And we're going to talk about perception more in depth in the next video. But perceptual set is another vocab word. So your expectations can influence what you perceive. So the context of a particular lesson or something that you're reading or something that you're hearing, the context can influence how you perceive it. The emotional state that you're in can influence, and then your motivation, okay? Those things can all influence your perception. And we're going to do an activity in class tomorrow that'll illustrate this a little bit better. All right, make sure that you're writing down any of your questions from this unit. Like I said, it's mostly vocab heavy, vocab based, and we'll do some activities with these so that you learn the vocab as well. But I will see you guys in class tomorrow. Bye-bye.